Okay, lab 7, templates and operator overloading. Hey, look, what we're going to do in class, we're going to do in here, and it looks like I actually started you off, which was kind of nice. So the purpose of the lab is to get you used to implementing templated classes with operating overload. Very powerful, but sometimes very cumbersome, as you saw when I tried to convert the class to a templated class, and then I had to move a lot of things around, and it was annoying. Oh well. You're going to implement a templated version of your array class, aka what you did last time, but now we're going to put it inside of a class. So here's the header file. Look, I gave it to you. Man, that was nice of me. But I did not tell you what the private content of your array class should be. Hey, I think we did that in class, so that shouldn't be too hard. But the idea of this lab is you're going to go into the code and implement these functions. So the array class, hopefully you all understand, is going to represent an array of elements, continuous. All right, public array. Do a deep copy of the array into the list. This one uses a pointer. Did we talk about deep copy and shallow copy? All right. Hey, we're going to go and use the board. Yeah. All right. So we have an array, and it's going to be a pointer. Let's just say it points to right here. And you have your elements 0, 1, 2, dot, 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 9,001. All right. So if we want to do a shallow copy, you're simply going to copy the pointer. So you have arrow right here, and I'm just copying this over here for emphasis. 0, 1, 2, dot, 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 9,001. Great. So a shallow copy will be copying the pointer from there to here. It's shallow because you're only copying the pointer. In other words, we copied the memory address from this guy down here. A deep copy that is dip. All right. Still on the board? Almost. All right. That looks like B. It's going to be so professional. Oh, yeah. So you have your arrow right here. It's pointing down here. 0, 1, 2, dot, 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 9,001. So with the deep copy, you're not going to copy the pointer. What you're actually going to do is first allocate a new amount of memory, create a new, copy the same size here, and then you're going to copy all the elements in there. Do y'all see the difference? So shallow, you're simply copying the pointer so that they both point to the same thing. In a deep copy, you're actually creating a new object based on the contents because you're going deep into the object and copying every single element out. In general, your object should be doing a deep copy because over here, if you make a shallow copy during constructor, then you're going to have two array objects that are pointing to the same piece of data, which is not what you semantically mean when you create a new array object. How are we doing? All right. So,
is there any advantage to shallow copy?
Yes. It does not take as long to perform. Because on this one, here you're just copying one variable to another. It's a simple copy on the computer. Very easy. Here you have to allocate a piece of memory, and then you have to copy every single variable over. This is what you meant. This is not what you meant. But in certain situations, it may be advantageous to do aliasing. We hopefully are not going to experience that in this class. All right, so you do a shallow copy. Look, we also are going to have a separate constructor. Notice up here I give you the array as well as the size of the array to copy in. In the next one, I'm giving you the array class itself and asking you to do a deep copy. These are two different constructors, but both of them need to be implemented. They both are going to do a deep copy. Y'all good with those two? All right. Get length, return the length of the array. Hey, look, I pass it in up here, so go ahead and return it down here. Index of returns the index in the array where the value is found, -1 if it's not present in the array. That was called search in the previous one, but now it's called remove. Or I'm sorry, now it's called index of. So there we go. Remove removes the item position by shifting later elements left. Hey, just like remove from the previous left. Retrieves the element of position post. Ooh, there's an operator overloading one. I don't know if I gave you the code for that or not. Let's find out. There we go. Oh, I did. So I gave you the code for that one. Beautiful. Wow, that certainly was nice of me to go ahead and put all this in there. Great. I even gave you a main? I even gave you a main. Wow. So I gave you the parameter or the function declaration for this one, so you can go ahead and implement it. This one I did not. So array subscript. You know, you have ARY sub 1, in this case, is the 1. That's all this is. Y'all see that? And the function, what you're being passed to that function is what this is right here, the integer. So it's a way to overload the solve brackets. Also be able to overload the double equals. Notice that I am passing you another array. They have to contain the same elements in the same order in order for it to be true. Otherwise it's false. They also have to be the same size, by the way. And free any memory used. So make sure that you do free your memory. Did I write some of the test cases for you? Ooh, that would be nice. No. I didn't think I did. We wrote a bunch of the test cases from last class, so you should be able to take those and convert them over if you need to. Memory management. All right, at this point in the autograder, it is going to give you up to -10% if you're leaking memory. So I highly recommend running Valgrind to make sure you are actually freeing all the memory. Otherwise, you will lose some points. And this should be due a week from today. Okay. Some of y'all mentioned that the autograder was not up and running last time. It was. The issue, one thing with the autograder is before it can respond, it has to be able to pull everything from your repository, which due to our network connection can take from 5 to 10 minutes, which means that GitHub may report that it's not connected at first. So give it a first time you put in your webhook, come back maybe 15 minutes later, and then try and do a push of something and see if it actually is hooked up. When I tried it right after class when y'all left, it worked just fine. So I think the issue is we just need to wait a little while the first time due to the fact that pulling your repository initially can take a very long time. Okay. Any other questions? Comments? Screams? Yes. Only internally?
Yes.
So, yeah, I guess we all are introverts, so it doesn't come out.
I just compartmentalize the whole thing.
You just hold it in forever?
Yeah.
Okay.
Put it all in their separate bowls.
It's where it will never ever explode.
Yep.
Yes, excellent.
It's got a lot of chains on it.
You got a lot of chains on it? Okay, yeah. Because that's how it works.
Yep.
No? No? All right. Any other questions? See, stopping real early, give you plenty of lab time so you can ask me questions during lab time while you're working on it. Since last time was a bit hectic. Do start thinking about Project 1. Hopefully you're starting to see a couple of tools you can use for Project 1. We'll revisit this or Project 1 again later, but make sure you start thinking about it because it can definitely trip you up. Alright, anything? Nothing? Alright, well have a good weekend.